My name is Osama.
My name is David.
My name is Assad. My name is Hamza.
My name is Dua, and we're going to teach you guys polynomials 2 unit.
My name is David. I'm going to be teaching you dividing polynomials. There are two methods you can use. You can use synthetic division or long division. We're going to start with long division. So for long division, the process is really easy. There are only 3 steps you need. First, divide the first terms. Second, multiply that result from the divisor, then subtract it from the dividend. Third step, repeat. So how do you write that equation? You take your divisor and you put it on the left, you take your quotient, you put it on the top, you take your dividend and you put it on the bottom. So for this example question, this part here would be our dividend and this part here will be our divisor. So this is how we write it. 2x plus 1, 4x squared plus 8x minus 5. We take our first term, we divide it by our first term here. So 4x squared divided by 2x gives us 2x. We take the 2x, we multiply it by our term here, 2x plus 1. So 2x times 2x gives you 4x squared. 2x times 1 gives you 2x. Then we subtract. We get 6x. Now we bring down the negative 5 and take our 6x divided by 2x, like we just did before. 6x divided by 2x gives you 3. We take the 3 multiplied by 2x plus 1. 3 times 2x plus 1 gives you 6x plus 3. We subtract, we get negative 5 minus 3. Negative 5 minus 3 gives us negative 8. 6x minus 6x gives us 0. So our remainder is negative 8. Now, this is how you write the answer. So you take your quotient first, 2x plus 3. Then you add your remainder over the divisor. And this is your answer. For synthetic division, you put your divisor on the left side, you make half a square, then you put your dividend on here. So an example question could be 3x cubed plus 4x squared minus 2x minus 1 divided by x plus 4. So this is how we write the question. First, you find what this bracket equals. So x plus 4 equals 0. So you find x equals negative 4. You put negative 4 on the left side. You write down the whole part of the equation in ascending order. If it was 3x cubed minus 2x minus 1, we didn't have the 4x squared here. We'd have to put a placeholder, and it would be 0x squared. But because we have 4x squared here, we don't need to do that. So first we bring the 3 down. Then we multiply it by negative 4. We get negative 12. 4 plus negative 12 gives you negative 8. Negative 8 times 4 gives you positive 32. Negative 2 plus 32 gives you 30. 30 times negative 4 gives you 100. Negative 120, which equals to negative 121. This is your remainder, negative 121. And this is how I write the answer. Three x squared minus 8x plus 30 plus your remainder over your divisor So we don't need this plus sign here. We can just put a negative since the remainder is negative. And this is your final answer.
So we're gonna fully factor 6x cubed plus 7x squared minus 9x plus 2. So first we need to find the multiples of 2. So two multiples are plus minus 1 and plus minus 2. Then we sub in, so let's take negative 2. We sub in negative 2 as x. So the question is px equals 6x cubed plus 7x squared minus 9x plus 2. We sub in negative 2 as x, as you see, and then we expand the brackets and multiply, and we get 0. So that means this is a factor. So next, we have to divide the equation. So we get 6x squared. Okay, so 6x squared times x is 6x cubed plus 12x squared. Multiply the bottom by negative 1 because we're subtracting, so negative, and then this becomes a negative. We get negative 5x squared minus 9x because you brought this term down. Negative 5x is another term. Minus 10. Multiply the bottom by negative. You get positive. You get 0 here, and then this is x. The last term is plus 2. So that would be 1. So x plus 2, you get 0. So this is one of the multiples. So you can write the equation like this: x plus 2 and 6x squared minus 5x plus 1. So now you can factor this out. Plus 2 and 2x minus 1 and 3x minus 1. So 6x cubed plus 7x squared minus 9x plus 2 is equal to x plus 2, 2x minus 1, and 3x minus 1. So the x's for that equation would be x equals to negative 2, positive 1/2, and positive 1 over 3. So remainder theorem. So we determine the remainder of this polynomial by when we divide it by x plus 1. So 1 minus 7x squared minus 6x plus 5, 3x squared plus 3x squared. So the remainder is 1. So how we would write remainder in this equation would be x squared minus 10x plus 4 plus 1 over x plus 1 times x plus 1 equals 3x cubed minus 7x squared minus 6x plus 5. Okay, done.
Hi guys, so it's Sama here, and I'm going to be doing communication for this unit. So the communication question we're looking at today is describe the rule of the real roots of a polynomial equation when solving the related inequality. So the rule of real roots is to tell us where the function touches the x-axis. This tells us where the function goes from negative to positive or goes back to the same side. So we determine this by looking at the quadratic formula. The quadratic formula determines if the roots will be real or imaginary, as if your answer for x is the root of a negative number, then it's imaginary. So imaginary roots cannot be used because they do not exist on the graph and therefore cannot be used for inequalities. And imaginary roots are roots that have imaginary numbers. Imaginary numbers are numbers which are multiples of I, which is the square root of -1. And if your root is a multiple of this, that means it's imaginary. On the other hand, we have real roots, which exist on the function and determine whether the function will change signs. So either it will go from being positive to negative, or either it will stay the same. So real roots are roots that does not contain I, and therefore can exist on the graph. Real roots are the only roots that we looked at when graphing polynomials. Okay, so once we have our real roots, we look at it if the sign will change or stay the same. The function sign changes when the order of the root is odd. So for that, we look at the order or the exponent on the root, which in this case is 3, which is an odd number. So we know that the sign will change. So the function sign stays the same when the order of the root is even. So for that, we look at the exponent again. And if the exponent is even, then we know that the function will stay on the same side, or the sign will stay the same. So we look at the graph over here. So the function will touch the x-axis and then go back onto the same side, staying positive. Okay, so let's look at an example. So the function we're looking at is, so you'd have to factor this first, obviously. And if this is the factored form that you get, and you have to graph this, you're going to look at the roots. So we look at this and we know that that root right there has an imaginary number in it, so we do not worry about that and we forget about it. So the only one that we would put on our graph would be this one, and that would be your function. So let's look at why we don't use that root. We don't use that root because it has an imaginary number in it, which means that that number does not exist on the function because it contains a negative root. So in conclusion, when we're looking at inequalities, you only look at real roots because those are the only ones that appear on the graph.
Hi guys, so I'm Dora Anjum and I'm going to teach you guys about applications for this unit. So the application questions that we're going to deal with is solving inequalities algebraically. So let's get started. So when we look at inequalities and word problems, it relates to real life situations. So let's take a situation over here. So the question is, the number n in hundreds of monarch butterflies fly south in the winter in t years is modeled by this function. When will there be more than 700 butterflies flying south? And let's assume that t is equal to 0 in the year 1999. So let's get started with this question. Okay, so the first thing we're going to start off by doing is writing this function as an inequality. So it says that it has to be more than 700 butterflies. So I wrote it like that in the beginning, and you rearrange the 7 to make it greater than 0. Once you do that, you get your equation like this. So from here, when you're dealing with inequalities, you want to factor it to get your roots. And when you're dealing with a polynomial, you use the factor theorem. So in the first step, I use a factor theorem, and you're supposed to find the values for 24 that will let the function equal 0, so the remainder will be 0. And that is when the x is equal to -2. So after using the factor theorem, we found out that x plus 2 is one factor of this polynomial. the next step we're going to use is synthetic division. So what this will do is further simplify it. So what we do is take the leading coefficients of the equation that we have, plug it in, and divide it by the factor. So for example, if there was a coefficient of 1 here, there's 2, -20, -24, so we put that here. And then how it works is that you bring the 1 down, put it there, multiply it by 2, take the answer, carry it on the other side, and then do -2 minus 2, find the answer, and then carry it on. Now, if you did it right, then your remainder should be 0. If you didn't, you need to go back and check your work. Now, since we got it 0, we know that this is going to be our simplified form, which is this, x squared minus 4x minus 12. So now we have this and x plus 2. What we need to do is further simplify this to get our roots, because our roots is what we need for our inequality interval, right? So once we factor this out, we get x minus 6, x plus 2, and x plus 2. So x in this case is representing time, right? So that means our x values are x is equal to 6 and x is equal to -2. Time cannot be negative, so therefore we cannot use these and these. So that means it has to be 6. Also, if you take a look at this chart here, remember when you have something of order 2, that means there's going to be a bounce like this, and it doesn't really pass through the axis. So therefore, you can't use this because it doesn't pass through it, and x, this would. So we're going to end up using this for our inequality chart. And I put the -2 here just to show you, but you wouldn't actually end up using it because time cannot be negative, and you wouldn't end up using this either, but for the sake of having an interval table, I put in their values. So what you would do for an inequality chart is end up finding the x values and plugging it into the equation to see if it would be positive or negative. So for example, let's take a look at this one. A value for time that would be between -2 and 6. So for example, let's choose 4. You plug the x values here and see if the answer would come out negative or positive. So when you have 4 minus 6, it's going to be a negative. When you have 4 plus 2, it's going to be a positive. And so that means f of x in total is going to be a negative, because a negative and a positive make a negative. Now, if we look at x being greater than 6, and it's, for example, 7, when you plug it in all these values, you're going to realize it's going to be a positive. So that means, and because it's positive and we want to see when our function is greater than 0, that means this is what we're going to end up using over here, right? So at the end, this is going to be our actual answer, this value, because that means on a graph, this is when x is going to be greater than 0, because it's positive. So that means our answer over here is going to be x, which is t in this case. When t is greater than 6, there will be more than 700 butterflies. So if you go back, you remember t was 0 in the year 1999. So what you would have to do is 1999 plus 6, and you would get 2005. And that is your answer. So there would be more than 700 butterflies in the year 2005. And this is how you solve an inequality question algebraically. So inequalities can be used in a lot of different situations, in real life situations too. So for example, it would help you find out when, in this case, butterflies would be flying south and if it would be increasing or decreasing. So in an inequality, you can use to find out when the function that represents a certain situation would be above 0 or below 0, so it would be negative or positive. And other situations that you can use it in is, for example, as stated in the textbook questions, for a company there would be more customers or less customers, or for a population-wise or stocks, and that's what inequalities can help you with overall, not just solving questions, but also real-life situations.
So, what is a complex number? Complex number is a number that is a multiple of I, or a real number like 1, 2, 3, or 4, something we know, added to I. So a complex number is 3 plus I is an example, or you could have 2 times I. And I is the square root of -1. And if you try to think of the square root of -1, it's kind of hard to imagine in your head, because we know that when you multiply 2 negatives together, or when you square a negative, the answer is always positive. And if you square a positive number, then the answer is always positive. So the square root of -1 exists on a different number line. Okay, so here's the real number line. You have just a bunch of points on here. And let's say this is 0, 1, 2, 3, 4. All the numbers we know, negatives. So if you were to map out the complex plane, it would look like this. It would be, you'd have 1 plus I here. Here's I. Here is negative I. Make that an I. And let's say you had 3 plus I. Well, that's 3 minus I. And then, okay, so if you had the function x squared plus 1, y equals x squared plus 1, and you were told, we know that by graphing this, it's a parabola with a vertical shift of 1 up. Okay, and in this case, x would actually be I. So we know that, oh, hold on. I squared equals negative 1. And when this function equals 0, you would have y equals negative 1 squared plus 1, which equals 0. So on the graph, there's no point that equals 0. But if the graph were 3D, it would come out at you, and this area over here, the shaded area, would come out at the paper and be 0. Okay, let's say you had the square root of negative 49. We know from last year, this is the same thing as the square root of negative 1 times 49. So we can factor this part out. It becomes 7 times the square root of 1, and that's the same thing as 7 times I. You got all that? Okay. So, now, if we have this question, a cubic function f of x equals x plus 1 bracket 1/2 x squared minus 2x plus 5 over 2. It has one real root and 2 imaginary roots. It's written in such a way that we know what the one real root is, and we know that it has 2 imaginary roots. And it's asking us to find the 2 imaginary roots. So we can, if we use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we already know this part. We already know x plus 1 is going to be 0. So, or, negative 1 plus 1. We know that the real root is negative 1. Because, yeah, negative 1 plus 1 equals 0. We can just ignore that part for now. Just think of this part as one quadratic, and we can just plug those in. So our a is 1/2. Our b is negative 2, and our c value is 5 over 2. So we plug those in, which is negative 2, or negative 2, plus or minus square root of negative 2 squared, minus 4 times 1/2 times 5 over 2, divided by 2 times 1/2. 2 times 1/2 is 1, so we can just ignore the whole bottom of this. We're left with negative 2, which is equal to 2 plus or minus square root of 4 minus 1/2 times 1/2, which is 5 over 4, minus 5 over 4 times 5 over 4, and we can simplify this further. 4 minus 5. So 2 plus or minus the square root of negative 1, and we know that's I. 2 plus or minus I, and then 2 plus I and 2 minus I are your 2 imaginary roots. Solved.